the recording. So sometimes in certain machines, in certain machines, there are pieces. Machines are godak parts. So when the machines are operating, these parts touch each other constantly. Touch friction. A friction with time, they wear and tear. Wear and tear given parts. Ogalanta personally experienced that the some other machines when they constantly operate for a long time, you are given wear and tear. Even tires, like vehicle tires, car use car you have to replace it, right? Because the tires also get worn off. Because when tires are rotating, there's definitely always friction between the tire and the ground or the road. So if friction is overcome, they were given. So one thing we can do for these kind of in that case friction is bad because friction causes wear and tear. There are methods that we can use to reduce friction. One is we can polish the surfaces. Because generally, already done last week we learned nature of the contact surface affects friction, right? Surface if it's rough, is the friction higher or lower? If the surface is rough, is the friction higher or lower?
Lower.
Okay, others? If the surface is rough, is the friction higher or lower? Others? I got a few answers. Lamai surface rough na friction vadi. Do you all remember last week? Last week api thibba object with the spring balance on two different surfaces, where one was slightly smoother, the other one was a little rough. And in the rough one, the limiting frictional force was higher. In the smooth surface, the limiting frictional force was lower. You have to refer to the previous day's work when you're coming the next day. So, eto surface rough friction vary. So if we want to reduce friction, we have to make that surface smooth. How can we make a surface smooth? How to make a surface smooth? All right, polishing. Using talc powder. What else? What else? Liane Paz just answer. Water up to a certain extent, but long term water use ka na amare. So ekak apite karanna puluwan, we can reduce the roughness of the surface by polishing the surface, as you all very clearly said. Or we can also use talc powder. The polish karanna sandpaper use kan pulanga. Sandpaper, or you can use there are different polishing creams and all that.
Needs to be right.
Not yet. Api me discuss karna gama, I'm just writing the points. I'll give you time to write. Let's just discuss. So we can use talc powder, as you said. Okay. Talc powder කියලා කියන්නේ මේවා මොනවාද අපේ baby powder. Baby powder විතරක්ම නෙමෙයි. I mean there are other powders which are not baby powder, like අර ඩාල්ෆාගේ powders තියෙන්නේ මොනවාද Enchant කියලා brand එකක් තියෙනවා මම දන්නේ අනිත් brands මොනවාද කියලා. So not always baby powder, but that kind of powders, yes. Then we can also use different lubricators. Lubricators කියලා කියන්නේ ළමයි anything that sort of helps two surfaces to slide past each other easier. Shweta Mangi on Kalana, you can actually use the board. 1 second, let me check that. You can use the board freely. My whiteboard ki link ki vanna hoga na main chat ke just click on that if this is not working. 1 second. All right. So ito ko to lubricators, yes. So when two surfaces are in contact with each other, lubricators make it so much easier for the two surfaces to slide between each other. Okay. So for an example for a lubricator is lubrication oil. और machine oil के लिए क्या ना गुड़ाक मिलावट machine oil के लिए समालावट दाना oils which help those machine parts to slide between each other. We can also use grease. Grease is also a lubricator. Or we can use graphite. What is graphite, Lamai? What is graphite? Hmm? Your pencil has graphite. No, your pencil is made of graphite. Graphite is mineral, yes. So graphite is not only used to make pencils, huh? We know graphite already it's carbon. Yeah, we did it. But anyways, graphite is also used for many other applications. Like here, for an example, lubricators. Then we can use something called ball bearings. Now, what are ball bearings? Ball bearings ke liye kya lamai menna me wage jatiya. This is the same picture that is on the textbook that I'm putting on the whiteboard. Ball bearings ke liye nikan choti choti bole wage thiye. අපි මේවා use කරනවා surfaces දෙකක් මැද. එතකොට those two surfaces will not directly slide between each other. Instead, there will be little ball bearings between the two surfaces. එතකොට බෝල ටික උඩ තමයි slide වෙන්නේ. So the two surfaces will not directly touch each other. Therefore, friction එකෙන් වෙන damages අඩුයි. Okay? So that is what ball bearings mean. So ball bearings are usually ගොඩක් use for rotating parts. Like, let me put that here. Especially, you can start writing now. For the rotating parts. Quickly start writing that. අපි තව විනාඩි 5න් මේක ඉවර කරමු. ඊට පස්සේ අපි 7th lesson එක කරමු. I'm quite excited to do the 7th lesson. Have you all done the 7th lesson at school, lamai? All right. How was it? Was it okay or difficult or easy or how was it? All right. So we'll do it today as well. It's one of my favorite lessons in chemistry to do. Okay, quickly write this. Okay. Make අඳින්න ඕනේ නෑ. අඳින්න ඕනේ නෑ. It's on the textbook. Make it fast. 2 minutes. All right, Lame. Now, advantages of friction. Now, actually, friction how will the surfaces be? If there is no friction, now let's say there's an object, surface, and there was no friction. Will it be easy for me to move this object or will it difficult for me to move this object? If there was no friction, now let me like just quickly draw a diagram. This is an object on this surface. I want to move this object. So if there was no friction, will it be easy or difficult for me to move this object? Is my question. I'm getting a few answers. Okay, others? I'm getting different answers, huh? No friction kyanne. Lama friction kyanne resistive force ka. When I'm trying to move an object or when I'm actually moving an object, the other surface is giving an opposite force to stop that motion. That is friction, right? No friction කියලා කියන්නේ අර opposite force එක නැති වෙනවා. So that means there is no force trying to stop the motion. That should make it easier for me to move the object. Is that clear? Friction කියලා කියන්නේ resistive force එකක් නේ. Friction is a force that is trying to stop the motion. No friction means there is no stopping the motion. So it will be very easy for me to move the object. Is that clear to everybody? Give me a thumbs up. I'm going to thumbs up if that's clear. Okay, others? Cool. Chalukya, Dihansa, Jaden, Kushit. I think others gave, no? Okay, I'll say that again, yes. Now, friction kela kyane resistive force. It's a force that is trying to stop the motion. Neither friction is, so when there is a motion about to happen or a motion happening, friction is the force given by the other surface that is in contact to stop the motion or to oppose the motion. So friction නැහැ කියන්නේ opposite force එකක් නැහැ. මේ motion එක stop කරන්න කියලා එකක් නැහැ. එතකොට හරියම ලේසි අපිට object එක move කරන්න. Okay. දැන් එතකොට මේකේ හොඳක් තියෙනවා නරකක් තියෙනවා. Let's imagine an instance where we are walking, right? When we are walking, my feet are in contact with the ground. Okay. එතකොට friction නැහැ කියන්නේ හරි ලේසි මට move වෙන්න. It's actually too easy for me to move. No friction නේ. That could cause slipping. මගේ feet වලයි ground එක අතරේ frictional force එකක් නැහැ කියලා කියන්නේ මට හරිම ලේසි move වෙන්න, right? No friction. හරි ලේසි කියලා කියන්නේ it's a little too easy. So චුට්ටෙත්තම් ටක් ගාලා ලිස්සනවා. Okay? But thankfully there is friction. So having friction is important because it's a little difficult for me to walk. අපි ඒක realize කරන්න නැතුනට it's a little difficult for me to walk and it's a good thing. මොකද ගොඩක් ඇවිදින ලේසි වෙනවා කියන අනිවාර්යෙන් ලිස්සනවා. But because of friction we don't always slip. But හිතන්න පොළවේ oil වගේ හැල්ල තියෙනවා කියලා ඔයගලගේ flow එකේ. Oil is like a lubrication. ඒතර friction අඩු වෙනවා. එතකොට ඔයාට ටක් ගාලා ලිස්සනවා. Friction අඩු වෙලාවට ආව ටක් ගාලා ලිස්සනවා. Friction වැඩි නම් ආව ටක් ගාලා ලිස්සන්නේ නැහැ. That means friction එක තියෙන එක හොඳයි. So imagine හරිම glossy මාර smooth tile එකක ඇවිදිනකොට again ආව ලිස්සන්න තියෙන chance එක වැඩි. But if you're walking on like the road, like tar දාපු road එකක් නැත්නම් gravel එහෙම තියෙන road එකක් නම් ඔයාව ලිස්සන්න තියෙන chance එක අඩුයි. So that shows our glossy flow එක තියෙන තන friction එක අඩුයිනේ. tar දාපු road එකේ friction වැඩි. So having friction is good. It's good for walking. Otherwise, we would slip wherever we go. So that in that case, it's an advantage of friction. Then, Namai, the other thing is when there are vehicles, right? Vehicles, there are tires. Okay. Now, as I said, between tires and the road, there is friction, and I told you that's why tires given. හිතන friction තිබුණ නැහැ කියලා මොකද වෙන්නේ එතකොට? Between the tires and the road, let's say there were no friction. What would happen? What would happen? Anamai, what would happen? If there were no friction between the tires and the road, what would happen? Give me a second. Right, yes. So there would be accidents because no friction means the tires could slip. අපි කියන්නේ skid වෙනවා කියලා. ටග්ගලා skid වෙලා ලිස්සලා ඒතර vehicles ලිස්සලා යනවා. That could cause accidents. But thankfully there is friction between tires and the road. Therefore we have a better control. ඒතර ලේසියෙන් ලිස්සන්නේ. Actually we are trying to increase the friction. Right? How do we do that? Tires, this picture I'm taking it straight away from the textbook. Tire surface එකේ මෙන්න මේ වගේ grooves තියෙනවා. Grooves are like these patterns, right? These patterns actually make the surface of the tire rough. Rough කියන්නේ friction වැඩි. Friction වැඩි කියන්නේ no slippery. It's easier to move. Obviously, then පාරක නම් friction තියෙන කොහොඳයි. Friction නැහැ කියන්නේ ලිස්සනවනේ. So these tires having, I'm sorry, the image is still uploading. My connection is not very strong. So, 1 second. All right. So the image actually was not uploaded. Let me try again. Can y'all hear me well, Amai? Give me a thumbs up. Okay. So our tires will grooves because of this friction is high. That is one thing, right? Then the other thing is coir ropes. Coir ropes කියලා කියන්නේ කඹ. කඹ දැකලා තියෙනවද? ලනු හරි කඹ හරි same, more or less the same thing. Have you all seen කඹ? Have you all used කඹ? කඹ අදින තරගෙදී මම කඹ තියෙන?
Yes.
Yes. So these කඹේ ළමයි හැදිලා තියෙන පොඩි coir fibers. ඔතලා තමයි කඹයක් හදන්නේ. coir rope එක හදන්නේ coir fibers. ඔතල තමයි හදන්නේ. This coir fiber is very rough. It's not smooth at all. මේක fiber එකක් ගත්තොත් හරිම rough මේක. ඒතර ඒ වගේ fibers දෙකක් තුනක් මෙහෙම ඔතලනේ හදන්නේ. So when these fibers are moving past each other, when they're sliding against each other, because they're so rough, the friction is so high. Rough කියන්නේ friction වැඩි. ඒකින්ද ඒගොල්ලන්ට easily move වෙන්න අමාරු. ඒකයි කම්බයකට ඕනම ලොකු weight එකක් දරා ගන්න පුළුවන්. Like a coir rope can actually handle a lot of weight because the friction is so high. I mean, හිතන coir rope එකේ මොකක්ද කෙල්ලලා තියෙනවා කියලා. ඒතර coir rope එක මෙහෙම ඇදෙනවානේ. Then the fibers will try to move. For the rope to be broken, the fibers will try to move. However, when the fibers are trying to move, the friction is so high that they will not be able to move. Right, so that is another advantage of friction. Lastly, last anyway, තව එකක් තමයි bike එක. Right, you can check page 107 on your textbook. මේ තියන්නේ this is a push bicycle. Just a foot bicycle, right? Push bicycle or foot bicycle, whatever. How do we apply brakes in a foot bicycle? උඩින් අර brake ඒ lever එක තද කරාම මෙන්න මෙතන තියෙනවා brake pads දෙක. See, this is one brake pad. On the other side also there's another brake pad. අපි අතරින් මෙම brake ගහන තද කරද්දී උඩ මේ handle එකෙන් තද කරද්දී wheel එක ළඟ brake pads දෙක මෙහෙම wheel එකට තද වෙනවා. So the wheel will stop rotating and the bicycle will stop. එතනත් friction තමයි වෙන්නේ. When the brake pads are pressing onto the wheel, that is friction. So a little similar to that is our modern brake system in vehicles like cars, vans, lorries. වගේ vehicles වල තියෙන brake system එකත් ඒ වගේ. When we step onto the brake pad, brake කියන්නේ accelerator එකයි brake එකයි ටික තියෙනවානේ. When we step onto the brake, what will happen is that force will come here and මෙන්න මෙතන තියෙනවා brake pads දෙකක්. And this is our tire, the wheel. So when we step onto the brakes, these two brake pads will come close to the tire or the wheel and press onto the wheel. Then the wheel will stop rotating. Again, there is friction involved. So these are the advantages of using friction. Is this clear, Lama? Give me a thumbs up if it's clear to all of you. Others? Okay, write a question. Write a question. Write 5 advantages of. Write 5 advantages of frictional forces write 5 advantages of frictional forces and briefly explain each. Briefly explain each. So this you can write as a homework, Lamai, not during the class. Let's not take the time from the class to do this. One question for that. Write 5 advantages of frictional forces and briefly explain. All right. Excuse me. Put the topic. Now we are jumping to the 7th lesson. Huh? 6th I told you there's a printed note, but I was not able to share it with you yet because there are some edits to do. But anyways, we'll do the 7th one, right? Liana, quantification of elements and compounds. Lesson 7, quantification of elements and compounds. Fifth lesson is over, yes. All right, Raman. So here what we are trying to do is we are trying to quantify elements and compounds, right? So we have talked about elements and compounds quite a bit. Chutta cup elements can in the 3rd lesson, which is structure of matter, right? So in that lesson, we talked about, that was actually our first chemistry lesson, right? We talked a bit about chemistry. It was quite a long lesson. Abhi compounds ke na chutta kata kara like when elements combine, they make compounds. Abhi ek elements combine kala balo by crossing valencies, right? So we talked about that also a bit. Now in this lesson, we are talking about quantifying. Quantifying means measuring. කොහොමද අපි මේ elements and compounds measure කරන්නේ? Okay. So එතකොට here, okay, so I have a question before we start. What do you think is a suitable unit to measure elements and compounds? What do you think is a suitable method to measure elements and compounds? Do you think kilograms would be okay? Do you think kilograms would be okay? Kilograms? Grams, do you think would be enough? Would be ideal? Grams? Yeah. So අපි දැනට දන්න units අපිට use කරන්න අමාරුයි. Because actually if you take, okay, let's say grams use කරන්න පුළුවන් කියලා. Actually, if you take the mass of one carbon atom, that is this much. (1.993) into 10 to the power minus 23 grams. This is the mass of one carbon atom in grams. So this is so small, make a 0.00000000000. Make it 23 times 0, and then 0.01993. That is an extremely small mass, right? So අපි grams වලින් අඳින ගියාම එහෙම එකක් නැහැ. Carbon common atom එක කියලා නැහැ. This is just an example. So this is a mass of one carbon atom. Okay. So if you take the mass of one sodium atom, that would be 3 point, I also can't remember my textbook because these values nobody has to memorize. Huh? Not even scientists have these memorized. So this is also an extremely small amount, right? 0.00000 So if you take the mass of a hydrogen atom, which is our simplest element, that is minus 24 grams. 1.674 into minus 10 to the power minus 24 grams. That means 0.0000024 times gila 1674. So these values are extremely small. This value, this value, this value, that is extremely small. So grams වලින් අපිට ගන්න පුළුවන් තමයි, but it's a little inconvenient to use this. Right? It's a little inconvenient to measure elements and compounds. Compounds හදන්නේ elements දෙකක් හරි කීපයක් හරි එකතු වෙලානේ. So measuring elements and compounds using grams is a little difficult. ඒක හින්දා අපිට grams, even nanograms, micrograms උත් ඇත්තටම ටිකක් අමාරුයි පාවිච්චි කරන්න. However, now we have a different unit. Okay, because we know grams, milligrams, micrograms, nanograms, ඒවා හරියන්නේ නැහැ කියලා. So we have a different unit. That unit we call it atomic mass unit. AMU. So this is a unit specifically used to measure elements and compounds. හරිද? Okay. So මම කියනවා ඕගලම් පොඩි කාලේ ඉගෙනගෙන තියෙන grams, milligrams and kilograms. Then at a certain age you learned about tons, right? So එතකොට the first day you learned about tons as a metric, you had not much of an idea about what a ton is. හැබැයි කවුරු හරි වාට ඇවිල්ලා කිව්වා 1 ton equals 1000 kilograms කියලා. Now you get a better idea. First time you learn about ton, somebody කියනවා ඔන්න ship එකක තියෙනවා 30 tons of something, and then මේ ship එකේ තියෙනවා 20 tons of this, and then මෙතන තියෙනවා 2 tons of something else. Likewise, ton කියන metric එක first time ඔයා අහද්දී you are sure that this is some unit, but you don't know about it. And you have not heard, so you don't understand what a ton is. හැබැයි මම හරි කවුරු ඇවිල්ලාට කියනවා you don't understand ton, but actually 1 ton is 1000 kilograms. Now kilograms is something that you know. එතකොට when I say 1 ton is equal to 1000 kilograms, now you understand the ton better, right? First time ton එක ඇහුවම නිකන් ton කිව්වා කියලා you don't know what it is, right? But mama කිව්වා දැන් kilograms දන්නවා ton දන්නේ නැහැ. But I come and tell you 1 ton is 1000 kilograms. Now you have a good understanding or a better understanding. Okay. එහෙනම් 1 ton කියන්නේ 1000 kilograms, 2 tons කියන්නේ 2000 kilograms, 10 ton කියන්නේ 10,000 kilograms. Likewise, you get a better understanding. Is that clear to you? Is that clear to you? Give me a thumbs up. Right. ඒ වගේ අද ඔයගොල්ලෝ ඉගෙන ගත්ත අලුත් unit එකක්. What is it? Atomic mass unit. Now I keep saying mu atomic mass unit. You don't know what this means because it's the first time you're hearing this, right? Ehena, I have to explain this in some way where it's easier for you to get an understanding about this. ඒකින්ද මම මෙන්න මෙහෙම කියනවා. Atomic mass unit එකක් කියලා කියන්නේ නිකන් atomic mass unit එක මොකක්ද දන්නේ නැහනේ. So atomic mass unit එකක් කියන්නේ mass of I'll explain this now, wait. This is what an atomic mass unit means. Atomic mass unit කියන්නේ you take the mass of the carbon atom or the isotope and you divide it by 12. මම මෙතන කියවනේ carbon වල atom එකක mass එක 1.993 into 10 to the power minus 23 grams. Okay, 1.993 එක ඕනේ. I will just say 1.99. So 1.99 into 10 to the power minus 23 grams. That I have to divide by 12. When you do this, you don't have to do this simplification for the exam. Let's just assume we did this simplification. You will get an answer like this. 1.66 into 10 to the power minus 24 grams. Then balanda yes, I'll explain. Now, when I say an atomic mass unit, this is the first time you are hearing this unit, so you don't know anything. But මම ඒක උගලන්ට තේරුම් ගන්න ලේසි වෙන්න I say atomic mass unit is you take the mass of a carbon atom and you divide it. මේ 612 isotope එක දැන්ට අමතක කරන්න. Just you take the mass of a carbon atom, you divide it by 12. So mass of a carbon atom is 1.99 into 10 to the power minus 23. So I take 1.99 into 10 to the power minus 23 grams and I divide it by 12. I get the answer as 1.66 into 10 to the power minus 24 grams. And now this is the value of one atomic mass unit. නැත්තම් මට මෙහෙම කියන්නත් පුළුවන්. One atomic mass unit is 1.66 into 10 to the power minus 24 grams. Now, atomic mass unit is a unit you don't know about. But grams is a unit that you know. එතකොට මම atomic mass unit එක gram විදියට කිව්වම you can understand it better, right? මම කිව්වම atomic mass unit කියන්නේ 1.66 into 10 to the power minus 24 grams. You can get a better understanding about what one atomic mass unit is. මෙතන අතරම 10 to the power, okay, so that's a good question. So 10 to the power minus 20, my calculation exam එකට එන්නේ නැහැ, don't worry about it. But because you asked that question, good, you are being curious. So let's discuss that. I like when you ask curious questions. 10 to the power minus 23 එක කොහොමද 10 to the power minus 24 උනේ? ඒක වෙන්නේ මෙහෙමයි. So 1.99 into 10 to the power minus 23 and 10 to the power minus 23 එක පැත්තකින් තියන්න. 1.99 I'm going to divide by 12. එතකොට මට එනවා 0.1 don't worry about it. So let's say because actually 1.66 is an approximation. ඒ කියන්නේ මෙයාව simplify කරාම අපිට එනවා 0.166 මෙතන තියෙන 10 to the power minus 23 නේ. එයාවත් දානවා මෙතන 10 to the power minus 23 කියලා. This is the answer that I actually get. 10 to the power minus 23 means මෙතන ඉඳන් 23 points ඉස්සරහට යන්න ඕනේ නේද decimal place එක. That's what 10 to the power minus 23 means, right? 10 to the power minus 23 means the decimal place has to go 23 times forward. Is that clear to all of you? Tanuj, is it clear? Okay. But සාමාන්‍ය scientific notation වල 0 point කියලා දාන්නේ නැහැ. හැම වෙලේම decimal place එකට කලින් value එක තියෙන එක නම්බරයක් හරි තියෙන්න ඕනේ. So usually we have to write it as 1.66. You can't put 0 at the front of a decimal place in scientific notation. But we know that 0 point ආවම මෙතන ඉඳන් 23 times ඉස්සරහට යන්න ඕනේ. But then decimal point එක තියෙන්නේ මෙතන. ඒ කියන්නේ තව එකක් මේ පැත්තට පැනලා decimal point එක. මෙතන ඉඳන් 23 points ඉස්සරහට යන්න ඕනේ නම් මෙතන ඉඳන් යනවා නම් තව extra එකක් ඉස්සරහට යන්න ඕනේ, right? That would be 24 points. එහෙනම් 10 to the power minus 24 grams. මෙතන ඉඳන් 23 ඉස්සරහට යන්න ඕනේ කියන්නේ මෙතන ඉඳන් නම් 24 යන්න ඕනේ. So 10 to the power minus 24 grams. That's how you get it. That calculation part, you don't need it for the exam. But Just it's good to know it's anyways mathematics. Ne? But okay, so look at this. You did not know what an atomic mass unit was earlier. But now you have a rough understanding. The atomic mass unit you know grams. When I just keep saying, okay, atomic mass unit, you don't know. But if I say atomic mass unit is 1.66 into 10 to the power minus 24 grams, since grams is a unit, you know, what podi idea ka kena atomic mass unit කියන්නේ මොකක්ද කියලා. ඒක තේරුණාද හැමෝටම? Give me a thumbs up please. Okay. Don't write yet because I have another point that I want to discuss here. මං කිව්වේ පස්සේ discuss කරමු කියලා. ඇයි මෙතන මෙහෙම carbon 612 කියනම isotope එකක් තියෙන්නේ? And do you remember what isotopes are first of all? What are isotopes? What are isotopes? Denadan Gutiaka. We did this not too long ago in the third lesson. Why are you all hesitating to answer? Why am I not getting instant replies? Cool. Yes. Different versions of the same chemical element. Isotope equals atomic numbers are equal. Okay. Partial answers dekaka. I'm glad that you at least 2 of you answered good, but quite partial. Full answer ka mata hambunne. Isotopes කියලා කියන්නේ එකම element එකේ එකම element එකේ කියන්නේ anyways atomic numbers are the same, but mass numbers are different. Those are what we call isotopes. If you remember hydrogen wala we learned about hydrogen 1 which is protium, hydrogen 1 2 which is deuterium, then hydrogen 1 3 which is tritium. Hydrogen wala atomic number is always 1. So protium walat atomic number 1, deuterium walat atomic number 1, tritium walat atomic number 1. Can you all hear me now? Am I still lagging? Can you all hear me? Okay. So protium walat atomic number 1, deuterium walat atomic number 1, tritium walat atomic number 1. Because hydrogen nang, you go to the ends of the universe, hydrogen nang, it will always be atomic number 1. Because atomic number is so unique to an element. But mass number could change. Meyagi mass number 1, Meyagi mass number 2, Meyagi mass number 3. Therefore, this is protium, this is deuterium, this is tritium. Now, these are isotopes. Same element. So, atomic number is the same, but mass numbers are different. Okay. ඒ වගේම ළමයි carbon වෙලා තියනවා 3 දෙනෙක් isotopes. Carbon. What is the atomic number of carbon ළමයි? ළමයි be more active දැන් මොකද මේ අද දවසේ is anything wrong? Is anything the problem? Usually you guys are more responsive than this. You respond faster than this. Because if you can't respond, no point, Nopi. Like I need your responses. I don't want to like teach to just the screen And you can't just stay like robots there. We have to interact. නැත්නම් ඔයාලට නින්දේ මටත් නින්දේ. Okay. So I have told you at the very beginning also, the problem with an online class not working is only if neither of us have discipline. ඔයගලන්ටයි මටයි දෙගොල්ලන්ටම discipline තියෙනවා නම් we can make the online class work, but you have to constantly interact. You know, one of the cons of an online class is I don't have my eyes on you. So you can do whatever the other things you want. ඔයගලන්ට self discipline නැත්තම් ඔයගලන් ගොළුව හැමතැනම යනවා ඔයගලන් other work කරනවා එහෙම. But I'm trying my best to keep you in the class. That's why I constantly ask questions. I check if you respond. That's why I ask if you understand. එතකොට ඔයගලා yes නම් thumbs up දෙනවා. Thumbs up දෙන්නේ නැත්te කවුද කියලා මම බලනවා. So I'm trying to constantly check on you. So ඒකින්ද just try to have that, like, you know, අහන ප්‍රශ්නට හරි උත්තර, because even if you, let's say ඔයාගේ ඔළුව ඇත්තටම naturally අපේ ඔළුව එහෙම යනවානේ. That's something that happens normally. Even that happens to me also. But අග්ගලා I must snap back වෙන්න ඕනේ. Okay? So that is why I ask a question to sort of awaken you. So when I ask a question, don't just be lazy. අනික කට්ටිය කීයද ආයෙනේ මම දාන්න ඕනේ එහෙම නෙමෙයි, හැමෝම reply කරා. That way I know you guys are actively listening. That could even motivate me more to teach you better, right? Because I know you guys are listening and not doing other work during the class. So carbon wala atomic number 6. In the periodic table, I told you to memorize the periodic table. We even checked a few weeks, I think. Carbon wala atomic number 6 kyane wherever you go in the universe, if you meet carbon will always have the atomic number 6. But mass number is different in these three. මෙයාගේ mass number 12, මෙයාගේ mass number 13, මෙයාගේ mass number 14. So මේ ඇවිල්ලා these are isotopes of carbon. Actually ළමයි nature එකේ වැඩිපුරම ඉන්නේ මෙයා. This is the most abundant isotope in the nature. That is why we use this isotope the most. මෙයා ටිකක් අඩුයි, මෙයාට අඩුයි. මෙයා තමයි ගොඩක්ම ඔය මේ carbon dating කියලා තියන්නේ. Have any of you heard carbon dating? Not dating, but carbon dating. Where what happens is like ගොඩක් archaeology වල ළමයි අපි history වල ඉගෙන ගන්නවානේ මේ අවද මේක prehistoric era එකේ මේක. I think some of you learn history in Sinhala. I was doing English medium too, but I learned history in Sinhala. But I heard in certain international schools not කොහොමද English වලින් history ඉගෙන ගන්න නේ. But anyhow, Praga-Itihasik or prehistoric or like this era or that era, may out there, kiki archaeological items they will date karana a system again carbon dating. Carbon dating is actually one of the methods where they use this particular isotope to determine the age of a particular archaeological artifact. Item. ඒක කොච්චර පරණයිද මොන history එකේ මොන era එකේද කියලා බලන්න පුළුවන් මේ isotope එක. Okay, so if you are interested, you can maybe watch a video about it. There are so many like little shorts on YouTube about this, which I'm pretty sure you're not going to watch. Mama keep watching it අපරාදේ. But බලමු එක්කෙනෙක්ට හරි එක interest එකක් આવොත් කියලා තමයි මම කිව්වේ. So you can just check it out. Because සමහර විට ඔයගලන්ට ප්‍රශ්නයක් ඇවිල්ලා ඇති ඒක when you're learning history. Okay, so they say මේක හම්බුණා මේ කාලේ මෙන්න මොනවාද අර මැටි වලින් ලිප්ස්ටික් ගාපු අය මට මතක නැහැ මොනවද තිබ්බේ කියලා එක items හම්බෙච්ච ඒවා තිබ්බනේ ඔය අර ලෙනෙයි මේ ලෙනෙයි. එතකොට ඔයගන්ට හිතිලා නැද්ද මේක කොහොමද මේ කාලෙමයි කියලා හරියටම ෂුවර් එකටම කිව්වේ කියලා? So maybe you may have had that question when you were learning those. So just remember, one of the methods to do that, obviously they use chemistry for that. One of the methods is using this carbon 614 isotope. That's called carbon dating. Okay. මොකද මේ ආතනම අපි කියනවා radioactive කියලා. එච්චර විස්තර ගන්නට ඕනේ නැහැ, but just for curiosity. Anyhow, now this 12, 13, 14 are mass numbers, right? Mass numbers are directly important for mass. And we are talking about mass. Mass, mass, mass. Grams means mass. We are talking about mass everywhere. If we are talking about mass, I can't just say carbon, take the mass of carbon atom. Because people will ask, okay, carbon atom තුනක් තියෙනවානේ. mass එක ගන්න නම් mass එකට carbon එක. වෙන දෙයක් ගන්න කිව්වොත් නම් කමක් නැහැ. atomic number තුනයාගෙම එකයිනේ. But mass එක ගන්න කිව්වම you have to be very specific because there are 3 carbon atoms with 3 different masses. So you have to be specific and say carbon 612 isotope එකේ mass එක. Because carbon 613 isotope has a different mass. Carbon 614 isotope has a different mass. That's why we are being very specific here. So the atomic mass unit is just one way of measuring the mass of elements and compounds. It's just a unit. Like a unit, grams, kilograms, milligrams, ton, unit. Is this clear to all of you? Give me a thumbs up, please. All right. I think we can start writing. Api podda poda liya karamu so that you have time to process everything we are learning. My lesson is important as I said earlier. You already put the topic, no? So, okay, let's write. Mathakam liyana. Then my Then we have a few other sentences, but overload kind of ban So I'll give you a few minutes and then I'll scroll the board down. While you write this, give me 2 minutes. Huh? Ma'am, sorry, had a connection issue. Can you all hear me? Lama, can you all hear me? All right. Did you all finish writing? Or were you all still writing? No, still writing. How the up to this point you were correct? Up to this point you finished. Okay. Then write atomic mass unit. Make it fast. For this, I have a few other sentences to add. I'll add them while you write. I just added one sentence here. Quickly write this. All right, Lamai, done? Everybody, shall we move on? Kwanita, are they still writing? If you're done, give me a thumbs up. All right. Okay, I think everybody has finished. We can move on. All right. So now we are going to be learning about a few. Lama මෙතන තව එක ඔයගොල්ලෝ මේ isotopes of carbon එක add කරගත්තද? To your note. Isotopes of carbon, did you add to your note? Okay, ඒක අපි චුට්ටක් add කරගමු. Some of you may have already drawn the sketch. If you draw this, like if you already drew the sketch, okay. If not, sketch එකත් එක්ක මෙන්න මේ sentence එක විතරක් දාගන්න ළමයි please. Please add this sentence only. Make it fast. All right. Now we are going to be learning a few more things. Okay. ලියන්න topic එකක් relative atomic mass. Relative atomic mass of elements. Brackets ඇතුලේ please put capital A මෙතන චූටියට subscript වගේ put R, simple R. Quickly put this topic and then put your pen aside. I will explain this. Okay. Now relative atomic mass is for elements. හරිද? Elements වලට අපි elements වල mass එක කියන්න ලේසි වෙන්න we are using a concept called relative atomic mass. Okay. So you will actually understand as we go on. There are a few methods to do this, right? So let's talk about method 1. Method 1 එකේ අපි relative atomic mass එක හොයන්නේ මෙහෙම. Relative atomic mass of an element is mass of an atom of the element we divide by 1/12 of mass of carbon 612 isotope. A කියන්නේ any element, the way how you can find the relative atomic mass is You take the mass of an atom of that element, you divide by 1 over 12 of mass of carbon 612 isotope. I'm pretty sure still you did not understand anything at the come. Let's do an example. An example. The mass of I'll use the example on the textbook. An oxygen atom is 2.66 into 10 to the power minus 23 grams. Make a value, you don't have to memorize. Huh? These are too complicated, they will give you. The mass of carbon 612 isotope is 1.99 into 10 to the power minus 23 grams. Find the relative atomic mass of oxygen. Okay. So, formula. What is our formula? Relative atomic mass of an element is mass of an atom of the element divided by 1 over 12 multiplied by mass of carbon 612 isotope. So, this is our formula. Then, we formula use කරන්න. Okay. Then, here we are talking about oxygen, right? So, I'm going to make a change. Mass of an oxygen atom. Divided by mass of an oxygen atom. One over 12 of mass of carbon 612 isotope. So in this example, we are going to be talking about the relative atomic mass of oxygen. Let's see. Now, mass of an oxygen atom, they have given 2.66 into 10 to the power minus 23 grams. Divided by formula ke 1 over 12 multiplied by mass of carbon 612 isotope, they have given that as well. Now we have to simplify. Grams cancel whenever 10 to the power minus 23, 10 to the power minus 23 cancel whenever. When you do the rest of the simplification, you get something like 16.02. When you round it off, you get 16. Does this have any units? No, because gram cancel. So relative atomic mass doesn't have a unit. Okay. So now let's go back to here. Relative atomic mass of any element is, relative atomic mass is just a concept, right? Relative atomic mass of any element is, you take the mass of that element, you divide by 1 over 12 of mass of carbon 612 isotope. For an example, they have given us the mass of oxygen atom as 2.66 into 10 to the power minus 23 grams. They have also given the mass of carbon 612 isotope as 1.99 into 10 to the power minus 23. And they're asking you to find the relative atomic mass. So, so here we are going to find about the relative atomic mass of oxygen. Right? Relative atomic mass of oxygen. So, mass of an oxygen atom, they have given 2.66 into 10 to the power minus 23 grams. Divided by 1 over 12 multiplied by mass of carbon 612 isotope. That is 1.99 into 10 to the power minus 23 grams. So, it's 10 to the power minus 23, 10 to the power minus 23 cancels off. Gram cancel off and we get 16. That is the answer. Did you all understand this? Give me a thumbs up, others. Okay. Can you all quickly copy this down before I talk about method 2? Method 1 ke muling copy karagana taggala. Make it really fast, huh? Then let's write about method 2. If you have any questions, you can ask, huh? So, good point, Chalukya. The May values they got 2.66 and 1.99 use gram, you get 16.04. That is true. But if you take the mass of oxygen, can you all hear me? Can you all hear me, Lama? Okay. So how they have taken 16.02 is that actually if you take the mass of oxygen atom, it's not just 2.66. It goes a long way, like 2.666.
And then she's taking Joanna out, so then we can come.
So 2.66, Kira, our numbers good, you know. Even if you take the mass of carbon at a 1.99 kilo, tama numbers godak tiyana. Okay, so they are talking about that entire division. If you want to metana 16.04 kilo dagatat kamak naha, because if you take these two numbers, yes. But if you take the actual like more decimal places, you actually get 16.02. Okay. Have you all finished writing, Lama? Give me a thumbs up if you have finished. Anybody who needs more time? Anybody who needs more time can let me know in the chat box. I could give you like 1 more minute. All done. Anita, done now. Give me a thumbs up. Make it fast. Stephanie, Sasheli, Kushit, Jaden, Dihansa, Chalukya, Anya. All right. Let's move on to method 2. Don't write anything. Now listen first. Huh? The method 1 में formula करें. I'm going to copy paste the same formula. And this is what I'm going to do. Look at this part. 1/12 of mass of carbon 612 isotope. 1/12 of mass of carbon 612 isotope means mass of carbon 612 isotope divided by 12, right? Mass of carbon 612 isotope divided by 12. Do you understand that is what this means? 1/12 of mass of carbon 612 isotope means mass of carbon 612 isotope divided by 2, right? Sorry, divided by 12, right? एक clear है मोटा में. So, do you remember here we learned something like this? Mame highlight kar pick na vitrak focus krana 1/12 of mass of carbon 612 isotope. In other words, mass of carbon 612 isotope divided by 12. Let's go up. Look at this one. Mass of carbon 612 isotope divided by 12 is equal to atomic mass unit. Instead of mass of carbon 612 isotope divided by 12, I can put atomic mass unit. Methana, instead of 1/12 of mass of carbon 612 isotope, එක්කොම erase කරලා මට ලියන්න පුළුවන් atomic mass unit here. Because 1/12 of mass of carbon 612 isotope or mass of carbon 612 isotope divided by 12 is actually atomic mass unit, right? That's equal to atomic mass unit. And I'm going to replace atomic mass unit. Is that clear to all of you? Okay. Just to check, we can do calculations exam. I don't know for term test they might give, because for term test they don't have if they don't have much to ask, they might give calculations. I don't know. Some school papers but for O levels, relative atomic mass calculations they will not give you, because calculations are quite complex. Decimals divide grangram, it's more complex. So they don't usually give for O levels and even for provincial papers, but I can't really give you much of a guarantee for school papers. So let's look at an example. අපි ගමු ටෙක්ස්ට්බුක් එකේ දීලා තියෙන example එකක්ම mass of a sodium atom is 3.819 into 10 to the power when minus 23 grams. Then now they give you value of atomic mass unities. මේකේ ඔයගලන් ගොඩක් අර හැම batch එකේම ළමයි අහන ප්‍රශ්නයක් තියෙනවා. Let's see if you will ask that question. Unities 1.67 10 to the power. So you might wonder, cell atomic mass unit, they said 1.66. Now they give it as 1.67. Don't worry too much about these decimal values, Namai, because decimal values are going on and on and on forever. Eva may round off color tiye. So just you, if they ever give you a calculation, use the data that they have given. Make a value memorize they always give you the values. Keep that in mind. Okay. Now we have to use this formula. Now here, relative atomic mass of sodium. Mass of an atom of sodium divided by atomic mass unit. Now we just have to substitute the values we are given with. Mass of an atom of sodium is 3.819 into 10 to the power minus 23 grams. Divided by atomic mass unit is now in 10 to the power minus 24. So, 10 to the power minus 23. But as I said again, you won't be given calculations. So don't worry too much. But then 1.67 into 10 to the power minus 24 grams is 0.167 into 10 to the power minus 23. Method minus 24 I made it minus 23. So grams, capilla, 10 to the power minus 23, 10 to the power minus 23 capilla. I get the answer as 23. This is my answer. Again, grams, capilla. So me at a unit take up now. Is this clear to you? Give me a thumbs up. Don't try it. Just let me know whether this is clear. Others? Anya, Chalukya, Jaden, Jevindu, Kushit, Rochelle, Sasheli, Tenuji. Okay, make a Liana Kaling. Anybody has any questions about these two methods? Any clarification you need? So, good luck, batches. Okay. Now, let's say you are given a calculation or some question. How do we know which method to use? Because now we are learning method 1 and we are also learning method 2. So how do we decide which method we are going to use for the calculation was a question I got asked a lot. There's a very clear and easy answer. The method that you are going to use depends on the information you are given with. As I said, none of these values you have to memorize. මේ වැලි එකක්වත් ඔයා memorize කරන්නේ නැහැ. ඔයා memorize කරන්නේ formula එක විතරයි. Only the equation you memorize, but any of these values you don't memorize. එතකොට හිතන්න question එකක ඔයාට දීලා තියෙනවා ඒ element එකේ atom එකක mass එකයි carbon 612 isotope එකේ mass එකයි කියලා. එහෙම දීලා තිබ්බොත් you have to use method 1 because method 2 එකේ carbon 612 isotope එකක් නැහැනේ. Then you have to use method 1. But if they give you the mass of an atom of that element and atomic mass unit, then you have to use method 2. Because method 1 use not information madi. So what the method you are using depends on the information you are given with. Is that clear? That's clear? All right. Can you all write okay, can you all write method 2, Lamai? Make it fast. I'll give you a few minutes to copy this down. Make it fast. If you have questions, please do ask. Done, Lamai? Thumbs up. Others, do you all need more time? Okay, seems like a lot of you are done. All right. Now, actually, this relative atomic mass is so much easier than actually calculating the mass. Mukada, baan me okkama values unit tekut na hai, nikan 23, 16. Hari lazy values tama yen. So therefore, we use relative atomic mass a lot. So for all the elements that have been recognized and identified so far, හැමකටම relative atomic mass එක already calculate කරලා තියෙනවා. So you don't have to calculate that. Okay. But we don't care about all the elements, no. We only care about the first 20 elements in the periodic table. If 20 elements වලටම relative atomic mass is already calculated. Can you go to page 125 on your textbook? There's a table there which says relative atomic masses of some elements. Can you all see that? Hydrogen get relative atomic mass of 1. It's already calculated, so you don't have to worry about it. Helium, it's 4. Atomic number ka මේ පැත්ත දීලා තියෙනවා relative atomic mass එක අනිත් පැත්ත දීලා තියෙනවා. I can't get the picture to the whiteboard, but I hope you all have the textbook, so you can take a look there. Then lithium wala relative atomic mass එක 7. Beryllium, it's 9. Boron, it's 11. Carbon, it's 12. Nitrogen, it's 14. Oxygen, it's 16. Fluorine, it's 19. Then fluorine, it's 19. Neon, it's 20. Sodium, it's 23. Magnesium, it's 24. Aluminium, it's 27. Silicon, it's 28. Phosphorus, 31. Sulfur, 32. Chlorine, 35.5. Argon, 40. Potassium, 39. Calcium, 40. So these are all the relative atomic masses of the first 20 elements. Because we only care about the first 20 elements, although there are like 115 elements that are discovered so far. So මේ හැම එකේම first 20 වල relative atomic masses මෙතන දීලා තියෙනවා, which have been calculated using one of these two methods. So you don't have to do the calculation. Scientists have already done it. Okay. So මේ values උත් ඇත්තටම you don't have to memorize. Okay, so I think that's a very good thing. මොකද සාමාන්‍ය mass values අපි as a standard in science we don't memorize them. Because masses can change and mass values can be a little complex. So generally we don't memorize mass values. So may values tika power you don't have to memorize. Is that clear to all of you? All right. Make ඔයගලන් ලියන්න ඕනේ නැහැ. This table you don't need to copy down to your notebook. So that is about relative atomic mass. Now we are going to move on to relative molecular mass. So put a topic, relative molecular mass. Symbol is capital M, subscript R. Topic එක දාගන්න ළමයි, give me 2 minutes. All right, Lamai, I'm sorry. Yes, so relative molecular mass. Now we talked about relative atomic mass. Relative atomic mass is for singular atoms. But always, if you look at the world of chemistry, not everything exists as atoms, right? Sometimes there are also groups of atoms, which we call as molecules. So relative molecular mass is for such groups of molecules. Okay, is that clear to all of you, Lamai? And also, can all of you hear me well? All right. Then relative atomic mass again, relative molecular mass again, we have three methods. First two methods are just like relative atomic mass. We'll discuss them. But the last method, which is method 3, is the most popular method. And that is the method that we are going to be using a lot, method 3. But method 1 and 2, අපි ඉගෙන ගන්න ඕනේ හින්දා ඒක ඉගෙන ගන්නවා. But method 3 will be the most used one. All right. So, මෙන්න මෙහෙමයි වෙන්නේ. Don't write yet, just listen. Relative molecular mass of any molecule is mass of the molecule you divide by same story, huh? 1/12 of mass of carbon 612 isotope. අරක වගේමයි. So let's look at an example real fast. අපි බලමු textbook because මේ values මටවත් කටපාඩම් නැහැ මතක නැහැ. So obviously I have to refer somewhere for values. As I said, usually mass values we don't memorize in science. So let's take carbon dioxide. Mass of a carbon dioxide molecule is 7.31 into 10 to the power minus 23 grams. Then mass of carbon 612 isotope is 1.99 into 10 to the power minus 23 grams. Find the relative molecular mass of carbon dioxide, which is a molecule. Carbon dioxide is CO2. So here you can see it's a group of atoms. There's one carbon atom and two oxygen atoms. So if I give a lot of relative atomic mass use bad, then we have to use relative molecular mass. Okay, so I will write the formula. Relative molecular mass of carbon dioxide is mass of carbon dioxide molecule divided by 1/12 of mass of carbon 612 isotope. Now we'll substitute. Carbon dioxide molecule has a mass of 7.31 into 10 to the power minus 23 grams divided by 1/12. Mass of carbon 612 isotope is 1.99 into 10 to the power minus 23 grams. So grams, capilla, 10 to the power minus 23, 10 to the power minus 23 capilla. When we do the simplification, we are left with 44. It's not exactly 44, but when we round off, it will be 44. This is the relative molecular mass of carbon dioxide according to method 1. Is that clear? Give me a thumbs up. Others? Anya, Dihansa, Kushit, Rochelle, Stephanie, Tenuji, Tarusha. Also, Neja, okay, no worries. Just follow up with the whiteboard note and check if you have missed anything. Huh? All right, start writing this, Lama. You put the topic already, right? Relative molecular mass. Method 1 ke liya make it fast. Lama, done writing? Not yet? Okay. I'll give you one more minute. Am I done? Others, have you all finished writing? All right. Okay. So since the time is up, we'll wrap up. I'll send you this whiteboard note as well. Then ඕගලන්ට මට චූටි දෙයක් කියන්න ඕනේ. Just give me 1 minute. I suppose that you may have been a little, how do you put it? A little confused because of this LMS situation, because I know that the link was given to some, the link was not sent to some. Of course, at the beginning of anything, there are going to be like a little bit of technical issues and all that, but I think a lot of you all received the link, which is a good thing. අනිත් අර paid unpaid සමහරගේ pay කරපු අයගේ unpaid කියලා වැටලා තියෙනවා. That is because it's still being uploaded. එහෙම error එකක් තියෙනවා සෙනුදී. What I would suggest is දැන් ඔය normal number එක තියෙන්නේ, which group එකේ තියෙන්නේ Miss Divya සමහරවිට මමත් එකෙන් ඉඳලා හිටලා text කරනවා, but Miss Divya තමයි ඒක use කරන්නේ. So you can text her and let her know that you did not receive it. You're supposed to receive it. හැබැයි සමහර payment ඒවා සමහර update කරලා නැහැ. So when you log in, sometimes it may say that you have not paid fees when you have already paid. So that is because they are still being updated. Because there was some issue with it. Product structure we had to redo it. That's why it got delayed a bit. But just do me a favor, do us a favor, and give us feedback. ඔයගලන්ට technical issue එකක් ආවොත් හරි login වෙන issue එකක් ආවොත් හරි මොකක් හරි වුණොත් ඒක communicate කරන්න. So help us improve the LMS. Okay? Because it's very important as the classes are expanding. Manually හැමදේම කරන්න අමාරුයි. Right? So earlier I was only one who was doing this. But then it was difficult for me to manually do it with other